Greetings and welcome to an episode of my video blog, OpenShift Outdoors. I'm your host, Char Groover, and today I'm going to be showing you how to set up a minimal but very powerful OpenShift home lab. And unlike some of my previous blog posts before I started this video series, this lab we're going to build with Red Hat OpenShift Official as opposed to the community supported sibling OKD. In a future post, we'll do the same thing with OKD, but lately I've been doing a lot of my lab work with OpenShift Official, and so I thought I'd show you guys how to install that as well. If you're familiar with some of my previous home lab work, you'll know that the work that I do is very opinionated to the Intel NUC form factor. So the lab that I'm going to show you how to build today is going to use one of these 13th generation Intel NUCs. I really like the 12th and the 13th generation because they added these two M2 slots for storage. Where previous generations of this small, slim form factor only had one slot for an 80 millimeter M2. This one has two, albeit the second one is shorter. But the reason that's important, especially for a single node OpenShift installation, is that it allows us to separate the installation of the OpenShift cluster itself and the underlying Red Hat Core OS from the storage that we're going to use for provisioning for our applications. So when you go get your Intel NUC, get a 12th or a 13th generation, get a little shorty M2 of at least 128 gigabytes, 256 if you can find one that you want to afford, and get an NVMe that is at least 1 terabyte, preferably two. This one is a 1 terabyte. And what we're going to do when we install this is the OpenShift cluster is going to go on this one with Red Hat Core OS. This one we're going to use for host path provisioner for applications and utilities that you will deploy in your cluster. The other thing that's important about this is 64 gigabytes of RAM. Go ahead and spend the extra few dollars. 32 will work, 64 is better. All right, it's actually more important that you have 64 gigabytes of RAM than you have the i7 core processor. This is a Core i7. You can work fine with the Core i3 or even the Core i5, which will give you a little more CPUs than the i3. What I like about this i7 is it's still affordable, but it gives me 16 CPUs. So with this build right here, I have 16 CPUs, 64 gigabytes of RAM, and 1 terabyte of NVMe, all dedicated to running whatever applications I choose to put on my single node OpenShift cluster. Okay, so that's the first thing you're going to need for this is an Intel server. Highly recommend the Intel NUC form factor. There are other machines out there that are similar. The fact that it's a NUC isn't quite as important as the fact that it's an Intel CPU, because that's what my instructions and everything are going to be based around. It's also important that you have 64 gig of RAM to run all of the apps and things you might want to put on here. And at least for this setup, these two drives and the distinction between them is important. You can do it with just one, and maybe in a future video I'll show you how to do that with my lab configuration, but for now this is opinionated to that. So that's the server. The other piece of gear that you need, and this one is highly opinionated, it's this GL-iNet GL-AXT 1800 travel router. The reason I've built my lab around these, I've actually been using GL-iNet travel routers for quite a while. That's because they run OpenWRT, which means that I can make them do a lot more than just be a Wi-Fi access point or Wi-Fi repeater. because with OpenWRT, I can install additional utilities, I can manipulate the operating system. OpenWRT has a fantastic command line interface as well as a graphical interface for configuring and managing it. And what I like about this particular model, and the reason that I'm using this particular model, is one, it has an external micro SD card. So I can increase the storage capacity of this thing because it's going to serve as our DNS server, our router, our firewall, as well as being the installation source for our cluster. Because our cluster is going to use Pixie, iPixie specifically, to boot the node and install the initial kernel and RAM disk. And all of those artifacts need to fit somewhere. So I'm using this micro SD card. Get at least a 64 gigabyte. What I'm using is a 128, and actually in some of them I've got a 256. Because in other cases I'll also use this to be the storage provisioner for providing CentOS Stream mirrors, or I've even run a Nexus, Sonatype Nexus artifact registry on this thing. So it's got CPU, it's got RAM, it can do a lot of work for you. All right. So this is the first video in this series. And I'm going to break this up into chunks. So this first one is covering the materials that you need to get. Go get your Intel server, like this little Nook. Go get your GL AXT 1800 router. That's going to be the hardware you'll need. I've got an example of it set up right over here. This is the machine that we're going to be installing here in a bit in another video in this playlist. The other thing that you need to do to follow along with this installation is go to my blog, upstreamwithoutapaddle.com. And the follow along instructions for this particular lab exercise are going to be in this link, Building a Single Node OpenShift Home Lab, the agent-based install. So you'll follow along here as we go through this video. The first thing I'll show you how to do is configure and install the utilities. But before you come back to go to that next video, there's one other thing that I need you to do. I need you to go to developers.redhat.com, and I need you to create a Red Hat developer account. Okay, so go to developers.redhat.com. I'm going to sign out here real quick so I can show you what you need to look at. You'll go to the top right hand corner of this page and you'll pick login and you'll pick register for a Red Hat account. Okay, why am I asking you to do this? I'm asking you to do this, one, because we're going to install OpenShift official. The other reason that I'm asking you to do this is that with a developer's account, you can get access to a ton of free, no strings attached stuff. There's lots of free iBooks, ebooks out there about developing with Quarkus, about managing Kubernetes and OpenShift environments. There's lots of free tutorials and demos, as well as it giving you access to like the developer sandbox or other things. And most important for this exercise, we're going to need it in order to get a pull secret so that we can download the artifacts to install our OpenShift cluster. Okay? So go to developers.redhat.com, get signed up for your account if you don't already have one. Go get the hardware that you're going to need for this. An Intel 12th gen or 13th generation NUC is what I recommend. And you're definitely going to need this GL-iNet AXT 1800 travel router, okay? Because the scripts we're going to do to install are very, very specific to this particular machine, okay? They're not crazy expensive. And in fact, this whole setup here that'll give you, you know, full network stack with DNS and everything, plus 64 gig of RAM, a terabyte of application storage, and 16 CPUs. This is going to run you somewhere in between $900 to $1,000, depending on, what current market prices is. Which is not too bad, especially if you compare that against, running the same type of infrastructure as an EC2 instance or a Google Compute node or something in Azure. This will be pretty affordable, and it's highly flexible. You can throw this in a bag and carry it with you anywhere you want to, and set it up on a picnic table when you get inspired to write code. All right, so that's the end of this introductory video. Go ahead and create your account, get the hardware that you're going to need, and come back to the next video in this series, and we'll start getting your lab set up and configured. All right, I'll see you in just a bit.